Hi friends, in this video let us solve common source amplifier related problems. Right? So the question is find small signal voltage gain, and they have given common source amplifier. Why it is common source amplifier? You see, this is drain, gate and source, and the source terminal is grounded, so it is common source. Right? And there is no source resistor. So it is basic common source amplifier. So I kindly request you to watch the video on basic common source amplifier and a common source amplifier with two resistors. Then only we can solve the problem very easily and you can understand. I put those videos. Kindly watch it before solving the problems. And they are given all the parameters. So whenever you want to solve the problems like this, you have to perform first DC analysis. DC analysis we have to perform. Right? So how can we perform DC analysis? While we performing DC analysis, we have to remove AC source. So this will go, right? And the capacitor will be open. For DC, AC source is 0, capacitor is open circuit. So we have only this part, right? So 10 volt, this one and this one, 5K, 8K, and the circuit will go like this. Then this one, and finally this. This is 30K. This is 82K, right? So first what we have to find, this is drain, gate and source. VGS I find. VGS means voltage between gate and source. VGS is, see here gate current is 0. So all the current coming here will go to here. So it is series resistance, so voltage will divide it. VGS equal to this resistor, total voltage 10. Why apply voltage equal to 30 divided by 30 plus 82. So I get VGS is equal to 2.67 volt. Then I find ID. What is ID? Let us assume the transistor in saturation. I assume and then I confirm later. For transistor in saturation, drain current is K into VGS minus VT squared. For that only I find VGS. So everything they have given, VGS, VT they have given, and K they have given. So substitute all the values. So K is 0.8, VGS 2.67 minus 1.5 whole square. What I get is ID is equal to 1.1 milliamps. Next I find VDS. VDS is equal to, you see what is VDS? The voltage between drain and source. So this is VDS. So this minus this drain current, total drop minus this one will give this. So VDS is equal to VDD minus ID RD. Everything we know. VDD is 10 volt, ID 1.1 milliamps, RD 5 kilo ohm. It is in the diagram. So I get VDS is equal to 4.45 volt. I assume transistor in saturation. For saturation, the condition is VDS must be greater than VGS minus VT. VDS is 4.45. VGS we found VGS is 2.6. ET 1.5. So surely 4.45 is greater than 2.6 minus 1.5. So transistor in saturation. So our assumption is right. Okay. So the amplifier in transition. So what is the gain for small signal voltage gain? The formula for common source amplifier is GM R0 parallel RD. So this I have derived in the video. Please refer it. R0 is a resistance due to channel length modulation. So otherwise we put simply R0. So we find everything. Right? What is R0? R0 is equal to 1 by lambda ID. Lambda they have given in the problem. So it is 1 by 0.01. ID is 1.11. So if you simplify, what you get is 90 kilo ohm. RD in the problem itself is there in circuit. GM is 2K VGS minus VT. So we have everything. K they have given 2 into K 0.8 VGS is 2.67 minus 1.5. So GM is 1.88 milliampere per volt. So we found all the things. So what is AV? AV is equal to minus GM minus 1.88 milliampere per volt. Right? R naught 90K, RD 5K. Right? So if you simplify, what you get is minus 1.55. So this is the small signal voltage gain. So what is this minus? There is a 180-degree phase shift between input and output. Right? So this is the answer. And the next problem is, so they have given common source amplifier. What we have to find? VGS, ID, VDS, and then AV. So this is source, gate, drain. So common source. See, source is common to both input and output, so it is common source. Okay. So first we have to carry out DC analysis. So first what we are going to find a DC analysis. In DC analysis, capacitor will be out. Right. So capacitor is open circuit and AC source will be 0. Right? So what we have to do, we have to remove. This one will go, this one will go. This is short, this is open, so totally it will be removed. So the circuit will be like this. So only we have this. Okay. So this is common source without any source resistor. This is 8.2K. This is 47K. This is 3.3K. This is 15 volt. Right? So here open. Capacitor is open. Okay. So first what I find VG. VG is voltage between the gate and the ground. VG is what? So this is here I0. Gate current is 0. So all the current coming here will be coming here only. There won't be any gate current to the MOS. So these two resistors are series. So I apply voltage divider. Total voltage. I have to find voltage across this. So 8.2 divided by 8.2 plus 47. So VG is 2.23 volt. Okay. Then I find Kn. Kn is, because whenever I want to find ID, all the things are required. Kn is equal to ID on plus VGS on minus VT. Right? So this one ID is fine. So when you substitute all the values, ID they have given. What is ID? ID is, you see, this is 200 milliamps. So 200 milliamps divided by VGS4 minus VT2. So they have given VGS on, everything they have given. See, this is VGS on, VT2 volt. So the answer is Kn is equal to 0.1 ampere per volt. Then I find ID. ID is equal to K VGS minus VT square. This is ID on. ID on is in the question. So K is 0.1. VGS minus VT 2.28. This is VGS on. This is VGS only. VT is 2 square. So what I get is ID is equal to 5.2 milliamps. Okay. Then VDS. VDS we know VDD minus IDRD. VDD 15 minus ID 5.2 into RD. RD is 3.3 into 10 power 3. So if you simplify, minus 2.15 volt. So we got VDS. Now AV we have to find it. AV, small signal voltage gain, minus GM RO. RO, whether they are given lambda? No, there is no lambda. So it is RD parallel. They are given load RL. So GM they are given in the problem. GM is given in the problem minus 23 millisiemens. RD is 3.3K. RO 33K. That is in the problem itself. Both are in the problem. From circuit RD and RL. If you simplify, GAV is equal to minus 69. So this is the way we have to solve the problems. And the next problem is find a voltage gain. Right? It is again common source amplifier. Right? So we have to find a voltage gain. So voltage gain from this we know. Here you see DC gate current is 0. This is for any MOSFET, right? Because the gate is insulated. So IG is equal to 0. Right? What is ID? First we are carrying out DC on this, so that's what we have done this. Right? So ID is equal to Kn VGS minus VT square. Okay. So ID is 0.5. Right? Okay. So I think it is given in the problem. Fine. You see, this is 0.5 milliampere. So this is even the IS. So IG 0. So ID is equal to IS only. So ID is 0.5 milliampere. Kn 1 milliampere per volt square. VGS minus VT is 0.8. So if you simplify, what is VGS? VGS is equal to 1.5 volt. That is VG minus VS. VG 0. Gate voltage is 0. So minus. So it is 1.5 volt. Okay. So next VDS. VDS is equal to VDD minus ID RD. VDD is 5 from the circuit. Right. ID 0.5. They are given. RD is 6.8. So ID 0.5 milliampere. This is RD 6.8 kilo ohm. So when you simplify this, what you get is 3.11 volt. This is VDS. Right? So whether transistor in saturation or not, then only we can proceed. Because in saturation only transistor works as amplifier. So VDS is greater than VGS minus VT. VDS is what you call it is 3.11. VGS is, from the problem we found, it is 1.51, it is 0.8. Surely it is greater than. So MOS in saturation. So it works as amplifier. Okay. Now for amplifier small signal voltage gain, AV is equal to minus GM. RD is there. RO is not there. Why RO is not here? We should not calculate RO. The reason we know, because lambda is given. So from the side, you see lambda channel length modulation is 0. So R0 is infinity. So we don't need to calculate it. So AB is equal to minus GM RD. So GM we have to find it. GM is equal to 2K VGS minus VT. So substitute all the value. 2 into K1 VGS 1.51 minus 0.8, that is equal to 1.42 milliamps per volt. So RD is in the problem. So AV is equal to, if you simplify, it is minus 9.656. Right? So that's all about this session. If you have any doubt, please ask me in comment section. Thank you.